good day again to whoever that's watching this video. Today, we from Group C1, we're going to explain about our report, which the title is based on activated carbon absorption. Myself, my name is Dinesh. Here are the list of my group mates: Izian Kalila binti Zakaria, Wang Kai Sheng, Nur Syahira binti Abdul Rahman, and Nur Aida Shasha binti Nawi. For my part, I'm going to explain about the introduction. So what is absorption? Absorption is a separation process where certain particles known as adsorbate bound to a surface known as adsorbent by either chemical or physical extraction. Adsorption process is analyzed into two fundamental contexts. They are isotherms and reaction kinetics. What is isotherms? Isotherms are empirical relations which are used to predict how much solute can be absorbed by activated carbon. The three main most well-known isotherms which are Langmuir, Friendlich, and linear. The next one is reaction kinetics. Reaction kinetics is the rate of chemical process which involves the elementary process, reaction, or steps. There are a lot of adsorbent type of adsorptions being used in industries. For example, there are activated alumina, silica gel, zeolites, and activated carbon. So let's have a look at the application of this adsorption process in industries. Adsorption process are being used in industries such as in preserving vacuum, clarification of sugar, chromatography analysis, and softening of hard water. So in our experiment 8, we have used activated carbon as our adsorbent and methylene blue solution as our adsorbate. So the main objective of this experiment is to study the adsorption kinetics and to find out the reaction kinetic constants. So let me pass the methodology part to my groupmate Wang Kai Sheng to explain more about it.
My name is Wang Kai Sheng. I'm going to present for methodology parts of our experiment 8, which is carbon absorption. So we have to fill the beaker with 1000 ml of water into the beaker with distilled water, and then we repeat for another 4 samples. As you can see in the video, we're going to take the methylene blue solid out of the water, and then we weigh it on the mass balance. So as you can see, our reading is 500 grams of methylene blue solids. Then we repeat for another 4 samples. So we have to weigh the activated carbon with 0.2 grams of activated carbon using the mass balance. Then we repeat for another 4 samples: 0.4, 0.6, 0.8, and 1.0 grams of carbon. Now we are going to insert the methylene blue solution into the beaker for 5 samples. One for 200, 400, 600, 800, and 1000. Then we're going to stir the beaker with a speed of 120 rpm. As you can see, the solution is become blue in color, and it is methylene blue solution. Okay, so the next step is we are going to insert the activated carbon into 5 different beakers. So after insert all the activated carbon, then we insert the carbon into all the beaker. Then we're going to take a sample from beaker to fill the 10 ml of small bottle. Then we repeat for another 4 beakers. As you can see, the speed is 120 rpm. Then we stir the solution for 10 minutes.
Okay, so first we have to insert the distilled water bottle into the spectrometer. Then we just close the opening. Just press the zero button to get the calibration marks. Then after that, we are going to remove the bottle of water. Then we take bottle of methylene blue solution and insert into the spectrometer. We close the cover. Then we're going to calculate the reading. So the reading is 0.367 as shown in the machine.
So I'm going to pass to my groupmate Ira, continue the part for result.
Assalamualaikum and hi. My name is Nashira binti Brahman and I would like to present about the result from our experiment. Okay, for the first one, for the experiment, we get the value for the absorbance. The value of the absorbance, we can put it into the data as you can see here. And then from the absorbance, we need to convert it into the concentration. The value for the concentration is we can get it from the linear equation from the theoretical graph, which is y equal to 0.098x plus 0.051. The value of the x is our concentration. The value of the concentration from the linear equation. After that, we put it into the table, which is table 2, the data of concentration of methylene blue solution. And then, after we get the value of the concentration, we plot it into the graph, which is the concentration of methylene blue solution against the time for each of the measurement, which is from the 200, 400, 600, 800, and 1000. And then, for the next one is, we're looking for the ratio of methylene blue concentration to its initial concentration. The formula is ratio equal to Ct over C0. Ct is for each of the time interval and C0 is for each of C0 is for the initial concentration. And then we put it into the table. Okay, next we're looking for the ratio of the methylene blue solution to its initial concentration. The formula is ratio equal to Ct over C0. Ct is for each of the time interval and C0 is for the initial value. And then we put into the table, which is table 3, the ratio of the methylene blue concentration to its initial concentration for every 10 minutes interval of different concentration of methylene blue solution. And then we're looking for the removal efficiency in 100%. And then the formula is removal efficiency equal to 1 minus Ct over C0. And then we times with the 100, which is we convert it into the percentage. The C0 is the initial concentration of methylene blue solution, and the Ct is concentration of the methylene blue at the time interval. And then we put it into the table, which is named as table for the data of removal efficiency in the 100% percentage. And then after we put into the table, we plot it into the graph, which is the removal efficiency versus time. We need to plot it for each of the measurement for 200, 400, 600, 800, and 1000. After that, we're looking for the equilibrium concentration. The formula for equilibrium concentration is QE equal to C0 minus CE divided by M times with the volume. For the volume is using for 1000 milliliter. And then the equilibrium concentration, we put it into the table, which is table of equilibrium concentration in methylene blue solution with the activated carbon, which is we name it as the QE, as you can see in the table below. After we're looking for the QE, we need to find for the concentration of the methylene blue absorbed by the carbon, which is we name it as the QT. The formula is C0 minus Ct divided by M times with the volume. And we use the same volume, which is 1000 milliliter. And then after we get the QT, we put it into the table, which we name as the data of concentration of methylene blue solution into the activated carbon, which is we name as QT. For our experiment, we need to observe for the pseudo first order and the pseudo second order. And then for pseudo first order, the formula is ln 1 minus Qt over Qe equal to ln Qe minus K1t. This is the same as the linear equation, which is y equal to mx plus c. And then after we get the table, we input it into the table, which is the table of ln 1 minus Qt divided by Qe. Qe is the equilibrium concentration and Qt is the concentration of the absorbed by the activated carbon. And then after we put it into the table, we need to plot it into the graph for each of the measurement. As you can see, this is the different color of the line, which is replaced for each of the measurement. For each of the measurement, for each of the line, we need to get the linear equation, which is y mx plus c. For us, this is because we need to looking for the K1 value. this is for the first order value. After we looking for the pseudo first order, we need to look for the pseudo second order. The formula is T over QT equal to 1 divided by KT times QE square plus 1 over QE times time. This is the same with the linear equation, which is y equal to mx plus c. And then we get the value of the t divided by qt. We need to put it into the graph. We need to plot it into the graph, which is the pseudo second order t divided by qt versus time. And then we plot the graph. After we plot the graph, it is the same with the pseudo first order. We need to find for the linear equation, which is y and x plus c. It is for us to look for the K2 value for the second order formula. Okay, for the last part of my result, we look for the K1 value from the pseudo first order equation, as I have said before this. And then we get it from the linear equation from each of the graph. And then we put it into the table so that we can see it very clearly. For example, this is for the 200, 400, 600, and 800, and 1000. And then this is for the pseudo first order. And then we look forward for the pseudo second order, which is the K2 value from the pseudo second order formula. And then we put it into the table for us. It's so easy for us to look for that, which is for 200, 400, 600, 800, and lastly for the 1000. This is all from my result part. And then I will pass it to my friend to discuss more about how this happened and what is the reason why this happened like this.
Hi guys, my name is Zakaria. I will proceed to the discussion part. Okay, as we all know, the objective of this experiment is to investigate the mass of activated carbon on adsorption kinetics. In this part, the concentration of methylene blue is constant at 30 mg. Meanwhile, the concentration of activated carbon varies from 200 mg to 1000 mg with interval of 200 mg. After each 10 minutes interval, a sample is taken from the solution and the sample absorbance is measured using the spectrometer. For the absorbance, the concentration of the methylene blue is calculated by using this formula. Okay, based on graph 1, concentration of methylene blue is very proportional with time. However, as you can see, the methylene blue solution is slightly decreasing over time. This is because the methylene blue solution is being used up by the adsorbent. Thus, methylene blue solution will decreasing. Okay, as we can see, the graph is the removal efficiency over time. From this figure, removal efficiency for 200 mg of activated carbon is the highest over time rather than others. This is due to the lowest concentration, so it is easier to use up by the adsorbents. Meanwhile, for 1000 mg, it is vice versa. This is because it is the highest concentration. Thus, it can be concluded that the mass of activated carbon affects the efficiency of removal of methylene blue from the solution. In addition, another objective of the experiment, which is to find out adsorption kinetics, can be obtained by using first order and second order kinetics model. The linearized form of the first and second order kinetics model are shown below. Shows a straight line, which is a good indicator that the process undergoes pseudo second order adsorption. Kinetics model. The values of QE, K, and H can be obtained from the slope and intercept of the graph. In conclusion, the adsorption of methylene blue solution by using activated carbon as the adsorbent follow a pseudo second order adsorption kinetics models. K1 and K2 indicates the rate constant of first and second pseudo adsorption kinetics model. Based on the results, the graph of log QE minus QT versus T is not a straight line. Therefore, it shows that this process did not follow a first order adsorption kinetics model.
In a conclusion, adsorption is a process in which a gas, liquid, or solid adheres to the surface of a solid or a liquid but does not penetrate it. For example, from this experiment, process of equilibrium adsorption isotherm for the blue removal of methylene blue from aqueous solution using activated carbon. Methylene blue is adsorbate and activated carbon is adsorbent. The objective of this experiment is to figure out the effect of mass of activated carbon on adsorption kinetics. From this experiment, the concentration of the methylene blue is constant at 50 mg, while the concentration of activated carbon varies from 200 mg to 1000 mg. Concentration of methylene blue solution versus time, removal efficiency versus time, pseudo first order versus time, and pseudo second order versus time were studied. We can conclude that methylene blue solution are decreasing with time, and the mass of activated carbon affect the efficiency of removal of methylene blue from the solution. The removal efficiency decreasing with increasing of mass or concentration. Okay, the most important application of activated carbon adsorption, where large amount of activated carbon are being consumed, is the purification of domestic and industrial wastewater.